Hi everyone, welcome back. So in this video, we're going to talk about ADaM training. So the ADaM Other, the part 6. So myself, Ali Sheikh, I'm the consultant at Trial Optima. Okay, so we have seen the BDS data structure and the basic data structures, occurrence data structure, and ADSL. So there are some data sets which are coming into this category, ADaM Other. Okay, let's dive into this video. Okay, so here as usual, we will be considering the version 1.1 and the section. If you check the 3.1.5, you will be seeing that variable naming fragments and ADaM data structures will be here. So 2.1, 4.2 ADaM data structures. So the main purpose is to define the use of ADaM other class in our analysis. Okay. So in this presentation, we'll be talk about the other classes. What are the ADaM other classes? What are other variables? ADaM other variables and the variable name fragments, and what is the ADAX structure, ADAX variables from IDSL. Okay, so the other class. So ADaM standard data structure should be used, when the standard data structure is capable of enabling the analysis. ADaM method should not be used because one did not feel like using BDS. So ADaM method class does not follow a set of structures and can be developed to accommodate the needs of given analysis. Okay. What is the purpose and the structure of it? So it supports the analysis that cannot be supported by predefined ADaM structures, ADSL, BDS, and occurrence data structures, and does not follow a set structures. Okay, so there is no structure set of the structure for this one, so it can be developed to accommodate the needs of specific analysis. Okay, and for the compliance requirements, ADaM fundamental principles, ADaM data naming conventions, ADaM variable naming conventions, and BDS or occurrence variables must conform to expected variables. So most common ADaM other domains are ADEX and ADV, so deviation part. While other class offer flexibility, it must still adhere to establish ADaM principles to maintain the standardization and traceability. So it is still following the ADaM principles, but it having more flexibility. Okay. So the other class, the ADaM other variables. So there are three categories. The structural flexibility. So what is the significance of other class data structures? So it has a structural flexibility. The variables can be customized to meet specific analytical needs and while maintaining the consistency with ADaM fundamental principles. Okay, and naming conventions must follow established ADaM variable naming conventions, include appropriate prefix and suffixes. And it also have the cross-structure consistency. When using the variables from other structures, the definition attributes must remain consistent. So, okay. Okay, so the next one will be the other class, the variable naming fragments. So you see the fragments are ZRY, FL, DT, TM. So what does it mean? Like suffix used in the naming grouping variables, where Y refers to the grouping scheme or algorithms. So FL suffix is used in the names of character flag variables when the valid values Y are null, Y are n no are null. The corresponding numeric version uses suffix FN. Okay, so the DT is suffix used in the names of numeric date variables, and the TM will be the time variables, and the DTM will be the date and time variables, and the DTF will be the time imputation flag, date imputation flag, and the time imputation flag, and the DY for the relative date. Okay, these are the suffix fragments of the suffix. And the BL will consider the baseline position related to the type of variable, not to be used to support more than one baseline definitions for eval in BDS datasets, and the change the follow-up on treatment position related to the type of variable. So run-in, screening, tapper, titer, position related to the type of variable. And U represent for the units in a suffix, and the WA represent the washout position related to the type of variable. Okay, so the other class example EDX. The purpose of the exposure dataset, ADaM datasets captures the drug administration data, including the dosing information, exposure duration, and compliance metrics. The structure typically includes variables for dose amount, units, frequency, route, duration, and cumulative exposure calculations. So it has analysis support, enables safety analysis related to the drug exposure, dose response relationship, and the treatment compliance assessments. So other class example ADX VF from ADSs. The table above shows the variables from the ADSs that are incorporated from the ADX dataset maintain the consistency across the atom structures while supporting exposure-specific analysis. So here we will be the predecessor means that we are bringing the variables from the ADSL datasets. So to maintain, so this is the dataset ADX. So there are many variables are coming from the ADSL, and we still have some exposure related information in the other ADaM other. So when designing the other class dataset, like ADX always include relevant ADSL variables to maintain the subject level context and enable seamless integration with other ADaM datasets. So understanding the other class in ADaM datasets, a technical deep dive into specialized dataset like AD, AEX, ADDV, exploring how they leverage SDTM source data and derive new variables for clinical analysis. So have the variables coming from the SDTM EX, for example, the treatment EXTRT, timing variables, exposure start dates and exposure end date, and the study dates, E and D by study day of start of the treatment, end of the treatment, records identifiers. Okay, so here okay, so the ADEX variables, so here for example the analysis treatment variables from SDTM and SUBX. So the ADX is a combination of both SDTM and supplementary called EX dataset. So direct SDTM mapping. So you can using the unique subject ID, exposure started, exposure end date, and exposure TRT. And the SUBX will be having the QNAM QLabel page for supplementary dataset. Additional administration data is not captured in the standard EX domain. Study specific exposure information is present for the sub EX. Studies. Okay. So derive and assign variables. So time related calculations, study day of start, study day of end. So all these variables will be present in a ADX, duration, the numeric format, and the duration in units, and the actual dose per administration, those units, and will be having the treatment continuation flag, analysis flag. These derived variables enable complex exposure analysis and dose response assessment critical for efficacy and safety evaluation. Okay, so next one. So ADDV, ADaM deviation. So this is the protocol deviation dataset overview. So analysis dataset. So analysis dataset for protocol deviation that captures the events where subjects did not follow the protocol as specified. Okay, so the subject was which what like they're not following the protocol as per the protocol, and those subjects, those capture of the events will be presented in the deviation datasets. So it contains both source HDTM variables from DV domain and derived variables that classify and categorize deviation for analysis. So analysis application is used to identify protocol violation patterns, assess impact on study validity, and determine the subject population for different analysis sets. So ADDV completes structure and variable sources. So ADSL integration. So most of the time will be the variables are coming from the ADSL as a predecessor. The key subject level variable from the ADSL provide context for each deviation. And also there are some other deviation category, standardized deviation term, and the reason for the deviation and analysis values. Okay, yeah, that's it for this short video, and I hope you like it, and we will continue for further classes. Thank you for so much for watching.